Hello guys, welcome you to the RTyoungStars. Um, as usual, we are not going to wait for anyone to join. The class starts at 1:30, so we start immediately. Okay, so yesterday we spoke about the introduction to robotics, and we made mention about some of the key components robots are supposed to be made up of. You get it? Today, we would be talking about one robotics kit, which is mostly used for beginners. You understand? So if you're a beginner, I encourage you to learn more about this particular kit before you um, proceed with your education in robotics. Okay, so we'll be talking about EV3. Okay, and the main thing we'll be talking about this EV3 kits is the hardware components. The hardware components of this EV3 kits. So before we continue, okay, so everyone, without wasting much time, let's just continue with the session. And as I said earlier on, yesterday, those who joined or those who watched the video on YouTube, we spoke about robotics in general. We defined robotics. We talked about some of the history in robotics, and we also talked about robots in general. And what I want you to recall from yesterday, or what I want you to know before we begin with today's session, is that robots are, mainly made up of sensors, actuators, and microcontrollers. Okay, so robots, when you pick a robot, you're supposed to see all these three things I mentioned on them, which is the actuators, the sensors, and the microcontrollers. These are constant things you need to see in a robot. If you don't see these things on them, then they are simple, machines. And yesterday we defined what a machine is, and we differentiated simple machines from robots. Okay, so today we'll be talking about this specific robotic kit, which is the EV3, mostly used in FL or First Lego League competitions, which is the challenge aspect. Okay, so today we'll be talking about some of the hardware of this particular kit, and we'll be explaining some of the sensors and how they work. If time permits us, okay, that is if time permits us, we would talk a little bit about the programming of this particular kit. Sorry. Okay, so without wasting much time, I think the 5 minutes is up, and we can't wait for more people to join. And as usual, every single part of this session is being recorded. Okay, so after this session, I'll post it. It will be available on the YouTube channel, the RichTechWorld channel, so that if you miss any part of it, or if you don't even understand, if you are in the group or you are in the session now and you don't understand, you can go there and have it. Okay, so without wasting much time, let me share my screen. So I'm going to share my screen. Okay. Yeah. So I hope each and everyone is seeing what I'm sharing right now. We have Lego Mindstorm EV3 basics. So we are going to learn about the basics of this particular EV3. If you've not seen the EV3 before, this is one here. So this is a simple driving based robot, okay, made out of the EV3 kits. Okay, so you see, we have a whole lot of things on this particular robot. Okay, so we'll be discussing them one after the other in the slides or the PDF. Okay, so let me continue sharing the screen now. Okay, so let's start. As I said earlier on, this particular EV3 kit is mostly used in competitions like FL and even in Ghana, RoboFest and Rise competitions. Okay, so if you know a bit about this, so there are certain things that are really not necessary. They are just things you understand by reading. Okay, so this is also a simple driving base made out of the EV3 kits we are going to talk about today. Okay, so let's start. So the first thing we are going to talk about, you see, yesterday we said they must have what? Robots must have one, a sensor, or sensors, 2 actuators, and then 3 microcontrollers. So these 3 things are what we need to see on a robot. So first of all, the microcontrollers or the controllers. So with the EV3 kits, this is the microcontroller. The picture you are seeing here is the microcontroller. It is called the intelligence brick, okay, or the brick. So that is the name given to it. And you can see some points under the PDF programs executed from the brick. So this is where the program is uploaded, okay, and this is where everything is processed. It has the microprocessor in here. It has the storage, the interfaces, what have you, all are in here. Okay, so this is the intelligent brick of the EV3, and you can see they've written on top there alphabet ports or alpha ports. So those are the ports for the alphabets. And we'll talk about those ports too and what they actually mean. We also have numeric ports, okay? And then we have the PC ports. Unlike the Arduino, we have the USB ports. With this one too, we have something called the PC port. So let's move on with it. So let's read some simple things we have here. So programs are downloaded to or created from the brick. Okay, so this is where the program I've mentioned that. And note, directly programming on the brick using its interface is possible, but a bit cumbersome. Okay, so programming with the brick is really difficult. So most of the time, the application mostly used is the what's the name, Lego Mindstorm application. Okay, that is a drag and drop application. Okay, and it's mostly used or it's really simple to be used by young or beginners just like you. Okay, so that is that. And you can also use Java in programming the EV3. Okay, you can also use Java by using the what's the name, Eclipse application. So with those applications, I'll leave the link in the WhatsApp group. So if you want to start learning the EV3, you can go there. And I also have we have tutorials on the EV3 on the RichTechWorld channel on YouTube. So if you want to start learning with learning robotics from scratch, and which I advise you to start with the EV3, you can go there and have those things. Okay. So let's move on. Let's move on. Okay, so I think Galaxy, I've seen you. Okay, so those who haven't joined yet, we will still provide the links to the tutorials right after the session. It will be on YouTube and other social media platforms. So if you want it, you can go for it. So let's move on. So aside the intelligence brick, okay, which falls under the microcontrollers, we spoke about it. Now we have 3 main parts: sensors, actuators, and microcontrollers. Sensors, actuators, and microcontrollers. Those are the 3 main parts. And we've said that right now, we've said that with the EV3, its microcontroller is the brick we have here, which I have one here, if you can see it. Let me stop sharing my screen so that you see it very well. So this is the intelligent brick for the EV3 microcontroller or EV3 kits. Okay, so that is that. So let's move on to the other parts. Let's move on to the other parts. So first of all, we have large motor. Okay, and yesterday we classified or we grouped most of the motors. In fact, all of the motors are actuators when it comes to robotics. Okay, with the 3 main categories, the motors fall under actuators. So with the EV3, it has 2 main types of motors: the large motor and the medium motor. Okay, the large motor and the medium motor. So this is the large motor. The first picture you are seeing right here, that is the large motor. Okay, so receives programmed instructions from the brick. You understand? So it received it receives programmed instructions from this particular brick. Okay, so this large motor takes information or instructions from the intelligence brick based on the program. Okay, that is why they made this really specific. Programmed what? Programmed instructions. So the intelligence brick do not give this large motor any instructions or anyhow, okay, or by itself. It gives this large motor programmed instructions. That means the instructions that have been, uploaded onto it. Okay, so that is it. So let's and it's also what it does heavy duty work. You understand? So heavy duty with lower gearing for mobility requirements. So mostly the large motor is used for the movements because it's able to, carry heavy duty, or it's used mostly for heavy duty work. You understand? So most students that goes for FL, RISE, and the other competitions use the large motors for the movement of the robot because all the weight is what exerted on it. Okay, so it's for heavy duty work. You can also use it for carrying other stuff. It depends on the kind of robot you are building. If it's a humanoid robot, you can make the large motor maybe carry stuff. It depends on the kind of robot you are building. Okay, and with yesterday we spoke about mobile robots and fixed robots. Okay, so the fixed robots are robots that do not move, and we gave an example to be those robots that are used for welding or carrying heavy duty or heavy works or heavy stuff in factories like the automobile companies, or I mean the companies that manufacture cars. So when you come to Ghana here, we have Kantanka having those kind of robots in manufacturing their cars. Okay, and if you want to build something small with like that with your Ev3, you can maybe use the large motor for the heavy, the part that will require more energy or more power. You understand? Then we also have the medium motor. Okay, so you should note the difference. We have the large motor, and this is the picture. Okay, and then we have the medium motor as well. Okay, so unlike the large motor that perform heavy duty work, the medium motor does not do heavy duty work, unlike the large motor. Okay, so if you are building a robot and then you would be raising, things that are heavier, depending on how heavy or lighter that particular thing you'll be using your robot for, you will choose the motors within them. Okay, so that is that for that. And then I have an example here. So it's the same picture you are seeing. Okay, so it also receives what? Programmed instructions from the brick. Okay, programmed instructions from the brick. So that is that for that too. And then you see light duty with higher gearing for quick response. Okay, so the medium motor is a bit faster than the large motor. Okay, it's a bit and then it has quick response when it comes to executing instructions. You understand, or taking instructions from the intelligence brick. And then it's not suitable for mobility. When we talk about mobility, it's about the movement of the robot. Okay, so the medium motor is not suitable for that. The large motor is what we mostly use. So if you take a look at this robot, let me show you the picture very well. So I hope you can see it. If you take a very good look at this robot, you can see the large motor here, and the large motor is what the whole weight of the robot is on. Okay, and you can see the medium motor here, and the medium motor is not really strong as compared to the large motor. That is why we didn't use it for the mobility aspect of the robot, or use it for the robot to move along with or move around with. Do you understand? So let's move on. Let's move on to the next things. Let me continue sharing the screen. So now we know about the large motors and then the medium motors. And since they are all motors, they will fall under the actuators. Okay, I want you to get these things right. If you pick a component of a robot, you should be able to classify it as an actuator, a sensor, or a microcontroller. Okay, actuators are things that receive instructions from the microcontroller to perform an action. Those are actuators. Okay, they perform actions or they perform the end result of the robot. They give out output. Okay. Okay, so let's classify them as output devices. Okay, they do most of the actions. Okay, and then sensors are things that will sense input to the microcontroller. They sense input to the microcontroller. Okay, so they are more or less like input devices. And we also have microcontrollers. They process everything based on the program it has been given. Okay, so I'm a programmer or I'm a robotics engineer and I'm building a robot. I should have, first of all, know what I want my robot to be used for and get components that will be mainly for that purpose. So let's move on. Now we know that large motors and the medium motors are under actuators. Okay, so let's move on to color sensors. Okay, so color sensors detects color. I hope you all can see. You all can see the slides I'm sharing. I don't know if you all can see well. Okay, so I think this way should be better. So this is where I am. The color sensors right here. Okay. So detects color differences and sends the data to the brick. You understand? So the color sensor will fall under the sensors aspect of robots. Okay, they sense information to the microcontroller to be processed based on the program the microcontroller has been given. So for instance, if what's the name? The program says if the color sensor sends a black color, the motor should move or rotate. Okay, so let me just do a simple connection right here for you to understand something. Okay, so give me a minute. Okay, so now we know what the color sensor does, right? It detects color differences. So if it's red, it will know that it's red. If it's green, it will detect. Okay, so those are the main things. And it also detects reflected intensity. When I talk about reflected intensity, it's the amount of light that is reflected back to the color sensor when this particular color sensor fires red lights or red rays. Okay, so when that ray is directed to a surface, okay, depending on how bright or dim the surface is, will determine also how much the rays will be reflected back to the color sensor. Okay, so this color sensor is able to detect reflected intensity, and we all know that for instance, let's just use black and white as an example. Black will reflect less intensity as compared to white because white is brighter than black. So that is the difference. So this color sensor is able to detect that as well. So this is a simple connection I have made. Let me make the screen bigger so that you see it well. So now we spoke about the microcontroller itself. Okay, this is the microcontroller itself, which processes everything. We've also talked about the large motor. Okay, this is the large motor. Now, as you can see, my large motor is connected towards the intelligence brick with this wire. We'll talk about the wire in the future very soon. And then we also have, what's the name, a color sensor here. The color sensor is also what's connected to the same intelligence brick. So we have all these two things connected to it. So let's just create a scenario here. Now I program this intelligence brick that if it receives a color sensor reading and the color sensor reading is equal to black, it should rotate this motor. This is something you need to understand. So the color sensor is what's the one acting as the input device, going to send the information or the data to the microcontroller to be processed. And if the information received from the color sensor is equal to what you used in your code, which we are saying is black, then the actuator also what perform the actions, and the action will be the instruction will be given from the microcontroller. So basically, this is a simple scenario I wanted to show you. So the the sensors, the microcontrollers, and then the actuators all work hand in hand to get the work done. Okay, so the specific work that your robot is built to perform, the color sensor, or I mean the sensors in general, the microcontrollers, and then also the actuators work hand in hand. So information is received by the sensors, the microcontroller process that information based on how it has been programmed, and then gives out the right or necessary output. Okay, and the output is performed by the actuators. Very simple. So we spoke about the intelligent brake, the large motor, medium motor. We've also spoke about the color sensor. Let's move to the ultrasonic sensor. Okay, so we have one here as well. So let me make it. So I hope you can see this is an ultrasonic sensor. Okay, and most of you will ask why the ultrasonic sensor has, this two eyes. Let me put it that way for you to understand. So it has, let's say, two eyes here. Okay, let's see from the picture itself. Okay, so you can see here there is one eye here and one eye here. Now let's talk a little bit about the ultrasonic sensor and how it's able to detect distance. Now let's read the functions here. Detect distance to an object and sense that data to the brake for possible actions according to programmed parameters. Okay, so that is also one tip you should know about the ultrasonic sensor. Any distance recorded or seen by or confirmed by the ultrasonic sensor is sent to the microcontroller to be processed. That is what that is talking about. And then using the same principle as bats and submarines, it uses echolocations by emitting an ultrasonic wave that is received back after bouncing off an object. The time it is, this is what you really have to know. Now, how the ultrasonic sensor is able to calculate for distance is what I'm trying to talk about. Now, we all know the speed of waves, and then we know ultrasonic waves is a form of sound waves, okay? And if you know the speed of sound, okay, you should be able to calculate for the distance. You should be able to calculate for the distance based on the time the sound waves traveled, or I mean, when to hit an obstacle and then reflected back to the ultrasonic sensor. So if you take a good look at the ultrasonic sensor, it has two eyes. One is the transmitter, the other is the receiver. Okay, or one is the trigger and then one is the echo. So the transmitter, what the transmitter does is it fires out an amount of sound waves or ultrasonic waves. Okay, and then immediately the waves is fired out by the ultrasonic sensor, it starts ticking. I mean, it starts counting the duration or the time that ultrasonic waves or the sound waves will travel and hit an obstacle. And we all know that when sound waves hit obstacles or opaque objects, it reflects back. Okay, so the ultrasonic sensor will wait for the time, will calculate for the time the sound waves travel from it to the particular object and the time it took to get back to it. Okay, so with that time and then with the speed of sound, we can calculate for the distance, whether in centimeters, whether in kilometers, whether in meters, we would get it. And we all know that the speed of sound is 343 meters per second. So if you want to calculate if let's say it takes, let's use this as an example. Let's say the ultrasonic waves take 10 seconds to reach the ultrasonic sensor. The only thing we need to do is to multiply the time it took for the sound waves to travel to the object and then back to the ultrasonic sensor by the speed of the ultrasonic waves. Then the answer we get, we divide it by 2. The reason why we divide the whole answer by 2 is because the distance will be duplicated since the ultrasonic waves went to the obstacle and came back. So it has covered twice that distance. So the answer you get, you divide the whole answer by 2. It's very simple. Okay, and we will find a day to talk more about the ultrasonic sensor alone. Okay, for you to get more, there is more to talk about that particular sensor. Okay, so these are also other sensors we have. We have the touch sensor, and if you hear touch sensor, you should know the function. Okay, it sends what states. So it has, I think, 3 main states. Okay, the pressed or bumped. It also has the press and hold, and then it has the hold and release. So let me find one for you. I think there is one here. Okay. So I'm not going to remove it out of the robot though. It looks stuck. So let's look right here. I'm going to stop sharing the screen so that you see it clearly. So let's take a look at this. So we can see the touch sensor here. I hope you all can see it. This is the touch sensor. And then we have the press and release. That is one state. We have the hold, release. That is another state. And then we have, let's continue with the other sensors. Hello, please mute yourself if you don't have any questions. If you have any question, raise your hand first before you ask the question. Okay, thank you very much. We also have the IR sensor or the infrared sensor. Okay, so the infrared sensor detects proximity to other objects, much like the ultrasonic sensor. Okay, and we've spoke about the ultrasonic sensor as its sensing distance. It's the same way the infrared sensor also sends distance between obstacles and sends that particular information to the microcontroller to be processed based on the program it has been given by its developer or the builder. Okay, so that is that for that too. We also have gyro sensor, and in most kits they call it the gyroscope. Okay, the gyro sensor detects orientation or rotation of the robot. So if you move even into the RichTechWorld channel on YouTube, we've made several tutorials how to use the gyro sensor to program the robot to, get a particular rotation, okay, an accurate rotation on that sort. Okay, so this is the gyro sensor. This is the physical gyro sensor I have here. I hope you can see it, and it has these 2 arrows. Okay, these 2 arrows. You will find one day and talk more about these sensors, okay, and how they work to get the distance, sorry, their inputs or whatever they are supposed to work for. For instance, the ultrasonic sensor is able to calculate for distance, the infrared sensor the same, the gyro sensor is for calculating for angles, and then color sensor is for getting the color differences and also the reflected intensities. Okay, so that is that for that. So yes, the gyro sensor detects the robot's orientation and rotation, motion, and sends the data to the brick. Okay, so for the robot to be able to rotate a particular rotation very accurate, The gyro sensor is the one that will communicate to the robot when it's making a turn that, okay, you've rotated this particular angle, so you should stop or not based on the program it has been given. So if you program your robot in such a way that it should get a 90-degree turn to the right or whatever you want to do, you just program it with a gyro sensor, and the gyro sensor will be communicating with the intelligence brake as to the particular type of rotation it is currently on or it is heading towards, so that it will stop at the right point at the right time. So basically, that is how the gyro sensor also works. So brake overview. So let me switch on this brake. Let me switch on this brake and we'll talk a little bit about some of the features. So yeah, I'm turning on the brake. It will take a while to boot up. So let's hold on for that. And I'm reminding you, for those who missed the session yesterday, it's in the group, it's in the WhatsApp group. So the link to the tutorials or the session is in the WhatsApp group. Okay. And today's attendance will be taken right after the session. Okay, so stay tuned for that too as well. Attendance will be taken. Okay, so yes, this is the, okay, so let's move. I hope you can see. I hope you can see my screen. Let's hold on. Okay. Yes, I hope you can see. I want everyone to mute. Okay. So I hope you can see. Let's move to the PDF so that you see better. So the first button you see, or the first palette you see here, or icon, okay, is the recent run programs. So the programs you upload to your microcontroller, or I mean your intelligence brake, the ones that you've recently run are those that shows there. Okay, so that is what you see. So the recently run programs, those are the things you see. And then the next one, right after the recently run icon, the next icon is the file navigation. So it contains the list of projects, folders, and programs. Okay, so for instance, you are going for a competition, you create a folder to keep your programs, okay, on your Lego Mindstorm application. You program them, and or you can, whenever you upload a code, okay, or you upload that particular program, it moves to the file navigation. Okay, so when you move to the file navigation, you will see all the list of programs you have on it. Okay, then you select the particular type. Let's say you have a program for mission 1. You go there, go to list of the missions. Let's say the name of the file is missions. Okay, when you tap on the file, that particular file called missions, you see the list of programs there. So basically, that is where your main programs are. So when you run any program from the file navigation, okay, that is when it will move to the recently run programs or run recent icon or the palette. Okay, so that is when it moves there. Then the next one we see here is the brake applications. Okay, so provides access to native apps such as pods view. So the pods view is when you can see all the components connected to your intelligent brake, the states, what they are currently measuring. For instance, if it's a sensor, what that sensor particularly is measuring, you will see it. If it's an actuator, the number of rotations or the angle it has rotated, you will see it over there. So that is that for that as well. Okay, so the last icon or the last palette you are going to see is the settings. And for settings, I expect you to know about that. But then it contains the general configuration of the intelligent brake. So if you want to change the name of your brake, you move there. Okay, if you want to set your sleep time, you move there. If you want to increase the volume of your brake, you move there. If you want to change the brake button color, you move there. If you want to connect your brake with your laptop through Bluetooth or Wi-Fi, you move there to do that. Okay, so basically that is what we do there. That is the software aspect. Okay. The next thing is the buttons on the brake. Okay, so the buttons are mostly used in navigating through your brake. Okay, and then if you want to turn on your intelligent brake, you press the middle button. Okay, so let me show you here the C. Okay, the button labeled C here. If your brake is off and you want to turn it on, you tap on that and then it comes on. If you want to turn it off, you press the B button twice. Okay, the B button twice until you see this pop-up menu. Then you select the tick sign or the correct sign there, and your intelligent brake will go off. So that is that for that as well. So yes, we are moving on to the, okay, I think, how long have we spent? Okay, so it's almost time. It's almost time. So we've talked about most of the things you need to know, most of the things you need to know about the hardware components of the Ev3 kits. Okay, so before we move to the programming, or before we talked about some of the programming of this or the applications used in programming this, how we program the sensors, the actuators, and whatever, or the sensors and actuators to work together, I want us to talk a little bit about the intelligence brake. Okay, I think we have 10 minutes more. We have 10 minutes more. We are going to make this really quick, and then I'm going to post the attendance link in the group so that those who are currently present with us can feel it. Okay, so the attendance link is in the chat now, so you can go in there for it. I hope you can see. If you can't see it, let me know so that I send it to you directly. Okay, so it's in the chat. You can go there for it. Okay, so this is the intelligence brake. Generally, this is the intelligence brake. We have these buttons for navigation, and I've already told you that the middle button we have here is to turn on the intelligence brake, and whenever you want to turn it off, you can tap this button twice like this, and then when this pop-up menu come, you just select the correct and then you turn it off. Okay, so that is it for that. We can also see some ports over here. The ports having A, B, and C. A, B, C, and D, okay? There are 4. And we also have the PC ports. Now, what these A, B, C ports means is basically for connecting your actuators. So the A, B, C, and D are for connecting actuators. And what are these actuators? The large motors, the medium motors, and what have you. So if you have any large motor, let's say if you have 4 large motors, they are supposed to be connected to the ports lettered A, B, C, and D. So basically your intelligent brake can carry or can contain 4 motors at a time. 4 motors at a time. Okay, so that is it for that. And then the PC port is the port through which you upload your code onto the intelligent brake. In case you don't want to use Wi-Fi or you don't want to use Bluetooth, you can just connect the downloading cable to this part and you connect it to your laptop or PC, then you upload your code onto it. Okay, so we also, unlike the ports lettered A, B, C, and D, we also have ports numbered 1, 2, 3, and 4. I hope you can all see it. So these ports are for the sensors. Okay, so if you want to connect your sensors to the intelligent brake, you can connect the sensors to the numbers. The sensors are not for the letters, and the actuators are not for the numbers. The sensors are for the ports numbered. Okay, and then the actuators are for the ports lettered. I mean A, B, C, and D. Okay, so Mark and Noel, I see your hands up. You can ask your question, unmute yourself and ask your question.
Please, how much tools do we need to create one robot?
You mean a robot from the EV3 kits?
Yes.
So when you buy the basic or the core set of the EV3, you would get most of the components that you will need. Okay, so when you buy the core kit, you are going to get actuators, which I spoke about, the large motors, and then the medium motors. Okay, and then you would also get sensors as well. So like the ultrasonic sensor, the basic sensors, you are going to get them in the kits. So basically you will get all the things you will need to build a basic robot. So if you need the EV3 kits, you can contact me in the WhatsApp group so that I direct you as to how to get the EV3 kits. Okay, so when you have the core set, you can build any robot you want to. Okay, it's only some complex robots that you would have to buy an extension kit for that, but I will explain to you that one some other time. So if you are interested in buying the EV3 kits, you can just let me know, and then I'll direct you as to how to get one. Okay, I hope you are answered.
Please, yes.
Thank you very much. Okay, so as I was saying, the ports lettered A, B, C, and D are for actuators, and the ports lettered 1, 2, 3, and 4 are also for what? Sensors. So those are the main things you need to know about the EV3 kits. So we also have the connecting wires. Now we spoke about the actuators, we spoke about the sensors, we spoke about the microcontroller. Okay, so how are these things connected together to form a robot? We use something called the connecting wires. So we have one here. So if you take a look at this robot that we've built here, you have all the components connected to the intelligent brake. Okay, so if it's a large motor, you will have a connecting wire connected to it and then to a port letter. Okay, if it's a sensor, which we have here, a color sensor here, you will have a connecting wire connected to it through to a port number because it's a sensor. Okay, so that is it. And then you will have some other kits materials that will help you to get the structure of the robot you need, okay, or to connect them together to make a whole robot like this. Okay, so yes, those who would like to get some of the EV3 kits can contact me. My number is in the WhatsApp group, so right after this session you can contact me. And I hope by now each and everyone has filled the attendance form. Okay, I expect you all to fill it so that I get your details from it. So we'll be ending the session in 2 minutes time. If you have any question concerning the actuators, the sensors, or the microcontrollers, you can ask. Okay, Mark and Noel, you can unmute yourself and ask your question.
Please, where can we get the microcontroller?
You mean the intelligent brake of the EV3 kits?
Yes, please.
Okay, so as I said earlier on, if you want to buy some, just contact me from the WhatsApp group. Okay, my number is in the WhatsApp group. Okay, so you contact me and then I will direct you as to how to get it. Okay.
Thank you.
Okay, sure. If you have any other question, Galaxy, if you have any question, you can ask. If not, we have a minute more to end the session. I hope by now each and everyone has filled the attendance form. So without wasting time, we are going to end today's session. And I'm reminding you that next week we will be talking about Arduino microcontrollers as well. Now we spoke about robotics in general. Now we know what robots are, we know histories about robotics, and then we know what robots are supposed to consist of. We've taken one robotics kit, which is the Ev3, and it's mostly the basic kit for starters like you. So we've discussed more about the hardware components. Okay, so next week we'll be talking about another kind of kit used mostly in robotics, and it's also for beginners. Okay, but then you can use it for complex projects as well, which is the Arduino kit. We'll be talking about the Arduino kit. We'll be talking about how to do your connections with the Arduino kit. You'll be building some simple projects, and I'll also introduce you to an online website that will help you to build applications without the kit itself. So thank you all for joining today. We are ending the session now.